Good day, everyone. I am Kenz O. Martinez, and I will be presenting my paper review of the research study entitled Simulation Model for Determining of Civil Engineering Project Earliest Finishing Time. This presentation is submitted in compliance with the requirements for MCE 2030, Modeling and Simulation of Engineering Systems, a subject under the Master's Degree program. So we have the presentation overview. Under this, we have letter A, who has or have done the work. Letter B, what were their goals or objectives. Letter C, what were the research questions, if any. Letter D, what were their methods in terms of but not limited to. Letter E, what were their findings. Letter F, what were the gaps in their studies or findings. And letter G, what is your takeaways on the research paper? So let's start for the first question. Who has or have done the work? In this research, it was conducted by 5 authors representing an international collaboration across Nigeria, China, and Kazakhstan. So we have the first author. He is Eberekuko Dixon Paru. He is a civil engineer in the Anambra State, Nigeria. He contributes to scholarly work through collaborative research, academic writing, and participation in institutional development. Next, we have Emmanuel Ogunjiyofor. He is a civil engineer in the Anambra State, Nigeria. So his work engages with scientific inquiry, research development, and academic excellence. Next, we have Chinedu Kingsley Achuki. He is a researcher with the Qingdao Institute of Bioenergy and Bioprocess Technology, Chinese Academy of Sciences, China. He contributes to laboratory-based research, experimental studies, and scholarly collaboration in the field of renewable biological energy technologies. Next, we have Emmanuel Emeka Okafor. He is affiliated with LN Gumilyov Eurasian National University, Kazakhstan. His academic focus supports international research growth, cross-border collaboration, and higher education development. And last, we have Daniel Daberekuko Ogbuehi. He is a researcher with Michael Okpara University of Agriculture, Omodike, Nigeria. His work reflects a commitment to agricultural innovation, scientific inquiry, and development-oriented research. Next, as a reader, I am interested in understanding the goals and objectives that guided the development of this research. So what were their goals and objectives? So the goals of this study is to develop a reliable simulation model that accurately determines the earliest possible completion time for civil engineering projects while accounting for uncertainties and risks inherent in construction activities. And its objectives is the study aims to develop an integrated simulation model combining Monte Carlo simulation and agent-based modeling to accurately predict the earliest possible completion time for civil engineering projects while accounting for key uncertainties like weather, resource availability, and site conditions. Next, we want to determine whether the study presents specific research questions. If so, what are they? So let's find out. As I read the study, I noticed that it does not explicitly state specific research questions. However, as a reader, certain questions arose for me while going through the first half of the paper. So this is my question. How can the earliest possible completion time for civil engineering projects be accurately predicted while accounting for the uncertainties and risk inherent in construction environments? Next, we will address this topic, which is divided into 3 specific questions. Number 1, how have they gathered relevant data? Number 2, how do they form the data set? And last, how do they process the data? So how have they gathered relevant data? So the researchers collected historical project data from project management offices and construction firms. It is focusing on a completed civil engineering projects with documented schedules, resource allocations, and risk factors. So they used a two-story building construction project as their primary case study. So it has a 14 activities with 3 duration estimates each. Next, who are the participants? So in this study, it does not involve human participants in the research, but the researchers relied on data from previous project files. So they used this data in a simulation application and conducted comparisons based on the results. Then how is the data gathering set up? So, historical project data were collected from various sources, so including project management offices, construction firms, and academic repositories. This data included detailed information on project schedules, task durations, resource allocations, and encountered risk. So this data, they used it on a software tools where they utilize simulation software such as At-Risk and AnyLogic. Next, what are the tools and techniques used in that data gathering? So first, let's have tools used in data gathering. So number 1 is the software tools. So under this, we have At-Risk for Monte Carlo simulation software for running probabilistic scenarios. Next, we have AnyLogic for agent-based modeling software for simulating project interactions. Then we have Microsoft Excel with RiskAmp add-in for PERT distribution calculations and data organization. And number 2, we have computational tools. It is a high-performance computing systems for processing extensive simulation iterations. Next, we have techniques used in data gathering. So we have first historical data collection. So the researcher gathered past project records from project management offices and construction firms. Next, we have 3-point estimation. So the researcher used the minimum value, the most likely value, and the maximum value from the result data. Next, we have literature review. So the researchers surveyed existing studies and models from academic journals, textbooks, and conference proceedings. Next, we have field experience analysis. So they also incorporated practical insights from construction industry professionals. Next, last, they use also data cleaning and preparation. So they removed inconsistencies and incomplete records. Next, how do they form the data set? First, project selection and breakdown. So the researchers select a two-story building construction project as their case study. So it has a 14 distinct activities or tasks. Next, 3-point estimation for each activity where it has the result of minimum value, the best case duration, most likely value, maximum value, or the worst case duration. Then, identification of uncertainty variables. Next, strategic planning table. Then, historical data integration. Next, mathematical model input preparation. Next, data validation. Next, simulation input data set. How do they clean the data? So in the research paper, the researchers stated that data cleaning and preparation was conducted, where the collected data was screened to remove inconsistencies and incomplete records. This step ensured that the data set used in the simulation was accurate, complete, and reliable. Next question, how do they process the data? So first, mathematical model application. So they apply the PERT or program evaluation and review technique distribution formulas to process the 3-point estimates. Next, Excel model setup with RISAMP add-in. They created an Excel-based model using the PERT distribution function. Next, Monte Carlo simulation processing. So they simulate iterations and they run 100 to 500 and 1000 trials. Then, number 4, statistical analysis of results. Next, probability distribution analysis, where they analyze the probability of completing the project within specific time frames. Next, comparison processing. They process the same data using both distributions to validate consistency. Next, critical path method analysis. Identified task dependencies and precedence relationships. Next, sensitivity analysis processing. They conducted sensitivity analysis to identify critical activities. Next, validation processing. And last is visualization and reporting. Next question is, what were their findings? So the question is, what were their findings? So in the research, these are the findings. So first, earliest finishing time. So the project can be completed in 225 days with 90% probability, which is 16 days earlier than traditional estimate of 241 days. Next, narrowed range. So simulation reduced the uncertainty range from 205 to 285 days initial estimate to 220 to 235 days actual probable range. Next, model consistency. So results remain stable across 100, 500, and 1000 iterations, with mean consistently at 225 days and standard deviation around 3.05 to 3.12 days. Next is critical activities. So superstructure, painting, and plastering work were identified as the most sensitive activities affecting project timeline. Next, improved accuracy. The simulation model demonstrated superior accuracy compared to traditional CPM when validated against historical project data. Then next, distribution validation. Both PERT and triangular distributions produced nearly identical results, 90% and 89.8% probability respectively. So, confirming model robustness. Next, practical value. The model successfully functioned as a decision support tool, enabling project managers to optimize schedules, allocate resources dynamically, and make informed risk management decisions based on probabilistic forecasts rather than single-point estimates. Next questions. What were the gaps in their studies or findings? So what were the gaps in their studies or findings? Number 1, limited documentation, insufficient details on data cleaning procedures and validation processes. Number 2, single case study, only tested on one two-story building project with 14 activities, not validated across diverse project types. Number 3, no real-time integration or model relies solely on historical data without capability for real-time updates during project execution. Number 4, incomplete uncertainty analysis. While 8 uncertainty variables were identified, their individual quantified impacts and interaction effects are not fully explained. Then last is, what is your takeaways on the research papers? So, this is my takeaways on the research paper. So, the research paper emphasizes the value of using simulation in construction scheduling, and it greatly captured my interest. While reading it, I became genuinely motivated to explore how simulation could be applied in my own workplace, where estimation, scheduling through Gantt charts, and progress reporting are part of our routine operations. I believe that gaining deeper knowledge and hands-on experience with this approach will significantly improve my efficiency and allow me to monitor project progress more accurately and effectively. So this is the end of my paper review for the simulation model for determining of civil engineering project earliest finishing time. Once again, I am Kenzo Martinez and thank you.